Let's start talking about weathering. There are two main types of weathering. We have physical weathering, where we have physical removal of the rock. Physical weathering can be caused by things like wind, water, ice, freeze-thaw cycles, and lastly, plant roots. Then we have chemical weathering. Chemical weathering is when we have a chemical change or a chemical reaction that happens that degrades the rock. Things like acid rain, also depending on how dissolvable the material is itself, something like calcium carbonate is highly dissolvable, so that will degrade quicker. And then things like lichen secrete an acid and break down the rock through the acids that it secretes. Erosion is the physical removal of rock particles. This can be done through very similar things as physical weathering, where we have wind, water, ice moving rock. We also can have animals that move rock through the burrowing into the soil. As these rock particles are removed from one area, they are then deposited in another area, and that's called deposition. So some low-lying areas are going to build up the rock that was removed from higher up areas. That is called deposition. So let's talk about how soil is formed. First of all, soil is a mixture of mineral and organic materials. And soil is not dirt. Dirt is what you get on your clothes, and it becomes dirty, where soil is the stuff that you dig outside. Soil is formed over hundreds of thousands of years from both physical and chemical weathering. We have a parent material, which is the type of rock that is weathered to become soil. Depending on the parent material is going to depend on the type of soil and the qualities of that soil that are available in that area. If we look at a young soil, a newly made soil, it's going to be mostly parent material and very little organics. So it's going to be mostly broken down rock and not a whole lot of organic. And so it's going to be very nutrient poor. An older soil is going to start to have an organic buildup and is going to become quite nutrient rich. And then an older soil that has been around for a while, where plants have utilized the nutrients, water has leached out the nutrients as well. So very, very old soils can also be nutrient poor because of all of the use from plants and from leaching from water. There are 5 factors that determine the properties of soil. We have parent material, climate, topography, organisms, and time. Let's talk about each one of these. The parent material is the underlying rock. Along the Atlantic coast of the United States, the major underlying rock is a silica quartz. This makes up a very sandy soil. It is nutrient poor, and because it's so sandy, it is nutrient poor. Whereas up in upstate New York and Vermont, their soil has a parent material of calcium carbonate, which increases the pH and actually makes it better for farming. Climate. In a freezing climate, you don't have any soil formation because the organics are basically not breaking down because they are frozen. In a hot, humid area, you're going to have a much more accelerated process of soil formation because things are breaking down faster. Topography. If you are on a steep slope, you're going to have more erosion. And if you are in a low-lying area, you're going to have much more deposition. The organisms that are there, if you have a lot of organics, you have a lot of change in what's decomposing. If you have a lot of plants, you might have plants removing nutrients, but then also plants can release organic acid into the soil, breaking down soil as well, breaking down rock as well. If you have tunneling animals, worms, rodents, that sort of thing, you're going to have a mixing of soil in different layers as well in that area. Also, with organisms, we have humans, and humans can greatly change soil quality. We can increase soil degradation through increased erosion by removing of plant material. Also with farming, we can increase the amount of nutrient withdrawal from that area. And then also compaction. From us just simply walking over an area, we compact the soil. And when you compact the soil, it changes the ability for it to retain moisture. So again, you're going to increase runoff with that. And it's not just us walking. We can also have a large farm area of a lot of cows walking in an area, compacting the soil and making it and making that area more susceptible to erosion. And then lastly, time. Over time, it changes of what's available, what's there, what can affect the soil. Now let's take a look at soil horizons. Here is a picture of a crosscut of soil. So you can see the different layers from the top of the crust down to the parent material. Soil horizons are not consistent in every area. Some soil horizons are larger in some areas. Some might even be non-existent. Let's go through each of the soil horizons. The outermost layer could be the O horizon. The O horizon is full of organics and is just organics. The O horizon is not found in every area. The O horizon is also known as humus. I've also heard this pronounced hummus. It is not the same stuff that you would be eating. That hummus is actually spelled differently. But this humus is essentially degraded organic material. When you feel this layer, it's very squishy and not very grainy. Then we have our A horizon. The A horizon is the topsoil. This is going to be where we have mostly organics and minerals. So this is where we'll have grasses growing. There'll be roots, there'll be bacteria, fungus, all sorts of organisms and different minerals in that area. Then we have the E horizon. The E horizon might not be there. This is going to be one that is not in every area. The E horizon is an area of leaching. So basically water has come through and removed some of the minerals in that area. This is called alluviation. So things like iron, aluminum, and organics have been leached out and then set down into the B horizon. So the E horizon can be found in either an O or an A. It's always found above the B horizon. It tends to be gray in color because these aluminums and irons have been leached out of that area. Then we have the B horizon. This is the subsoil. There's very little organics in this. At the very top of the B, you might have a couple of roots from larger trees, but essentially this is going to be pretty much free of organics. Then we have the C horizon, which is very similar to the parent material. So it's just going to be basically broken up parent material. And lastly, we have the R horizon, which is the parent material itself. It's the bedrock. So these are going to be all influenced on the area that they're in, the amount of erosion that's happening, the amount of human interaction that's happening, the organisms that are there, depending on the types of soils that you have is going to depend on what the horizons are going to look like. Let's talk about the physical properties of soil. We have 3 sizes of particles. We have sand, silt, and clay. Sand is the largest particle, silt is a medium-sized particle, and clay is going to be the smallest sized particle. The type of soil that you have is going to depend on the percentages of sand, silt, and clay within the soil. If you have a high amount of clay, the particles can compact a lot easier because they are so small, making very little space in between each of those particles, making it very difficult for something like water to get through. If you have a lot of sand particles, because the way that sand sits and it's larger, you have a lot more holes in between the particles and it allows for more water to get through. So if you had pure sand, it's going to be very porous and water is going to travel right on through. If you have pure clay, because it is so solid, it's not going to let water through. If you think of what your coffee mug is made out of, clay that has been essentially baked, water is not getting through. So it makes a great vessel for us to hold water in because the particles are so tightly knit together and don't let water pass through. So the percentages of sand, silt, and clay are going to allow for more drainage, less drainage, and allow for different properties of what could grow in that area. Here is a soil triangle. This triangle has all the different types of soils that there are based on the percentages of sand, silt, and clay within the soil. We will be practicing on how to use this. Essentially, you figure out the percentages of each of these particle sizes, and you see where those three intersect, and that is a type of soil that you have, and then you can determine what you need to do with the soil if you wanted to do something like growing something, or if you wanted to build a building somewhere, what you would need to do to make that soil amenable to whatever you are doing with that soil. Then our chemical properties of soil. Clay has a negative charge and attracts positive minerals. And because it can attract the positive minerals, it can kind of hold on to some of those minerals. So it could be potentially good for growing plants because the clay is holding on to those minerals that would be necessary for plant growth. Now, if we have more than 20% clay, we are going to have a hard time with water drainage, and then the plants will become waterlogged and won't be able to grow. So clay is good for holding onto those minerals, but we can't have too much clay because it won't let water through. So one of the things that we can measure is the cation exchange capacity. The cation exchange capacity is essentially how well the soil can hold on to and exchange those mineral cations. We also want to take a look at soil bases, which are calcium, magnesium, potassium, and sodium. And then soil acids, which are aluminum and hydrogen. Soil acids can be detrimental to plant growth. So soil bases can be used to neutralize those soil acids. So soil bases are good for plant growth. So when you have a good balance of the cation exchange and soil bases, it allows for good plant growth. And lastly, let's talk about biological properties. Biological properties would be things like fungus, bacteria, protozoa, rodents, and earthworms. These are all biologics that affect the soil formation. Fungi, bacteria, and protozoa are somewhere between 80 to 90% of the biologicals that are found in soil. These organisms are very important for a lot of nutrient exchange within the soil. If you remember, bacteria are highly important for the transformation of nitrogen, especially nitrogen fixation in the soil, so that way it can be uptaken by plants. Fungus and protozoa often, and earthworms are detritivores or decomposers. Detritivores are basically breaking down the dead bodies of plants and animals, and then decomposers are essentially breaking down the organics further for further nutrient exchange. So that is soil formation. Thanks for watching. See you next week.